Good morning, good afternoon, and good evening, everyone who's joining us for the webinar on Isobenefit Urbanism. So, great. So, I will just begin with a short introduction about Isobenefit Urbanism. In the early 2010s, Isobenefit Urbanism proposed cities where each point can reach continuous natural areas.
Hello, can you hear me?
Yes, Luca, we can hear you. Yes, and you are
just the test
from your
work.
Will you share your screen?
Okay, so this makes things easier.
Yeah.
Great. So
I'll wait. Okay.
Okay, great. So I'll just continue with the short introduction on Isobenefit Urbanism, and then I'll introduce all the speakers. And so Isobenefit Urbanism proposed cities where each point can reach continuous natural areas, job, location, centralities, shops, amenities, as well as the usual daily activities by walking or cycling. And Isobenefit Urbanism adds proximity to centralities and nature within a mile, and an isobenefic genetic code, DNA, implemented by a self-planning algorithm, generating infinite urban phenotypes for a sole urban genotype. So thank you everyone for joining who's here today. We have three very distinguished speakers who are going to present on this topic of Isobenefit Urbanism. And for all the people who are attending, I would request them to just type their questions during the presentations in the chat. And at the end, we'll have 15 minutes for Q&A where we can ask all the questions that are in the chat with for the speakers. So our first speaker is Luca De Acci. Professor Luca De Acci is from Polytechnic of Turin, and he has a polytrack educational path covering urban engineering, science of cities, economic assessments, urbanism, and anthropology. He is the former head of urban environment, sustainability, and climate change at the Erasmus University Rotterdam at IHS, and visiting researcher at, among many, the University of Oxford, University of Cambridge, and ETH Zurich. Luca has worked on projects for the World Bank, Asian Development Bank, European Commission, Engineering and Physical Sciences Research Council, Lincoln Institute of Land Policy, and currently for a Grand Challenges Small Grant from University College, London. He is known for his theories on isobenefit urbanism. So without further ado, I present to you Luca De Acci.
Luca, if you could please unmute yourself.
Hello, yes. Thank you very much for the introduction. And
you will need to share your screen. So on top,
exactly.
You will need to turn screen share on. You should have a little icon that says,
Because there is the good news that is working now.
Yes.
Share. Oh, fantastic.
Great.
Okay, can you see the presentation, right?
We can. You need to make it full screen. Yeah.
Fantastic. Okay, and so thank you for your invitation, and also for Tommaso and Frank to be here. And this is a definition that you can find somewhere about isobenefit urbanism. And first of all, the word iso or iso means equal, and benefit here is referred to the benefit from reaching amenities such as green space, centralities, shops, schools, services, and so on. So isobenefit urbanism is a morphogenetic code. Morphogenetic simply means morpho is for the shape, genetic is what originate and change this form, the form of the city. So morphogenetic code designed to promote a working city where one can reach. So working city in this case is intended as that you can reach the following amenities listed by walking. That's why it's also called the 1 mile city. In a recent paper with Professor David Bannister from Oxford, we called the green 1 mile city instead of isobenefit urbanism.
Luca,
and
sorry, can you make your presentation full screen maybe? Because I think it's still At least the way I see it is, it's not playing the slide.
Yeah. For me, my monitor is full screen.
Can everybody else see it full screen?
No.
No, it seems that it's not. So maybe try
Now
again.
is no. It's not.
No.
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 Strange. I'm sharing the monitor in the full screen. Let me see.
Maybe from the Presentazione tab, and then you can
Presentazione, so slides.
Play from the
On the
beginning.
presentation, I don't see.
No.
And just say by screen monitor.
Or if you press F5, that might work.
So let me do I share and try screen then.
Perhaps that's a way.
Before I was sharing the application. Okay, here is this entire screen. Can you see now?
Yes.
Yes, this is better.
Yeah.
Thank you. Yeah, great.
And in this link, you can. I did just a few days ago. I'm collecting information here and there about the Isobenefit urbanism, and you can find a collection of a few videos summarizing the concept. And here is a few media who recently mentioned about that, but you can see this in the link. These two from my university, this from MIT Technology Review. And here there are some visionary potential views about these cities, how they may look like. And you can see that you can always see the elements about relative density in terms of physical proximity, not necessarily in terms of inhabitants per kilometer square, but always connected with the green, and not just visually, but physically. And as you can see, there are no cars. And the code, the code is the following. It's very simple. The rule number one is each building, later we intend a residential building. So each building should reach within, let's say, 1 mile, so 50 minutes walking, the ordinary daily points, so the shops, the local schools, the post office, and so on, and a centrality. For centrality, here we mean the classical city center, or the new centralities as La Défense in Paris, for example, or in Rotterdam, if you see the area around, if you're in Rotterdam, the area around New York Hotel, that is quite a new centralities. When I was there the first time 20 years ago, there was almost nothing there. So a concentration is a kind of central business district. And a natural area. For natural area, I especially wrote natural area, not just park, urban park, because I also want to mean the wild field, let's say, not just the natural park. And the second rule is that these buildings should be close under aspects, because there is no specific street rules. You can change within the code as you wish, but should be close to each other for at least 1 kilometer square. So close to each other, this is to avoid that once you implement the code, you generate the overall urban sprawl, overall dispersed suburban area. And for at least 1 kilometer square, because once you generate the model, once you make the model running, I mean, if you don't write this condition, you may have a very, very small unit that's not even big enough to have the urban or village atmosphere. And every centralities should be interconnected via public transport, ideally to free up the green, the soil, the land, meaning or under or above. So SkyTrain or the also natural areas should be interconnected. This is flexible, this last rule. You can also relax without having this. And now, if you summarize this into 3 color cells, you can call the black the building area, like that. The white, the centrality, like that. And the green, the green. You may see, for your curiosity, the 3 pictures that are moving on the right, is a Python code that is been implementing, and you can see the different type of evolution that you have following these rules. And okay, you can also, so these are the three main cells: green, build, and centrality. And now we quickly see how this may work. After a short introduction between the planning versus self-organization, some of you listening may already have thought about this now how we fit this almost spontaneous emergence with a strong planning, even if this spontaneous emergence that you can see from this code is still built within these two macro rules. And this is the interesting bit, that is an interplay between macro planning, as we saw before here. Some of you may recognize, especially the architects, most of them, and the spontaneity, the emerging system without no one in control. And so in our case, we have one genotype, the code that I showed before. We can generate infinite Horman forms, well, or near infinite Horman form. As for the plant, depending from where the lights, the wind, the structure, the obstacle, and so on, she changes, as well as the city. So how it works, I will try to keep this in maximum 5 minutes and then I finish. This is to give you the idea about what actually is. And later you will see with Tommaso this apply with the QGIS plugin. And so the white cell is the centrality, and the black one are residential building. Imagine to start like that. Rule number 1A, within 1.5 kilometers, 1 mile, or 50 minutes walking from the centrality, you must have the residential building. So no one of the residential building should be above these distances, this distance. So literally mean that within this circle, you can build whatever you want, it doesn't matter. But if you want to build outside, you can still do it, but you have to add a new centrality somehow. It doesn't matter where, as long as there, for example, anywhere, it doesn't matter, as long as it's within this. So you can already see this interplay, right, between the top control, but the flexibility too. You can build wherever, as long as this is the underground philosophy. The same for the green. So let's have the same circle. Okay, so from there, 1 kilometer, well, 1 kilometer, 1 mile, 1.5 kilometer, 50 minutes, doesn't matter, it's flexible, no is the concept. You can reach within a reasonable distance by walking, the main things, in this case, the green. So again, you can build whatever you want within that green, because you can still reach within 1 kilometer, in this case, the green area. But if you do that, you don't anymore. Let's take, for example, a blue. Now we'll check a blue one, if I remember well, it was blue. Wait, this blue. You see, within 1 kilometer, it cannot reach, just for a bit, but still, it cannot reach the green. So it doesn't work. You can see. So you can do that, for example, and then it's working. So you can understand the infinite or near infinite scenario that you can have, the flexibility behind this approach. And okay, that's mostly done. Here is the question of being interconnected. So at least 1 kilometer square, doesn't matter the shape, of course. Here is a circle, but it can be a line, can be dendritic, it can be whatever, but at least the distances. And now, if you overlap, the same for the green, if you decide to have interconnected green, so this rule is satisfied, but if you build in the yellow, you see the yellow, then it doesn't work anymore because it's not anymore interconnected, the green, it's not anymore 1 kilometer, at least square the green size. So you should find other solution, doesn't matter where. Now, you can imagine that if you apply all these rules, you can do by hand, but it would be better to have something more automatic as a QGIS plugin that Tommaso Gabrieli will show you later. Here, and then I conclude my 15 minutes, they are almost finishing. This is there are some examples. These are made literally by hand a few years ago. So the time you can see, is from left to right. The classical is the first that you can see with the picture on the top on the left. And the counterpart of the isobenefit urbanism, they can have different shapes. All of them satisfy. This is what Tommaso is going to talk, and this is some simulations. You can have fun. Is already alive, the code. This is a Python code that wrote Michele Vota a few years ago, and is alive. So if you're able to do it, you can change the parameters, keeping constant the same code. Look at how many different scenarios you can have. So we don't have one isobenefit city. We have numerous, infinite. And there are several types of advantages you can imagine for the green assets, from the green itself, and there are more technical visualization, but they all say that, for example, you can see the diagram on the bottom. You can see the orange and the blue lines. That is the distance that a classical under us, the business as usual city grow. The more grow, and the more far away you need to walk to reach the centrality and the green. Why there is a benefit urbanism, the yellow and the violet one, the bottom, they're still constant. So it doesn't matter how big the mega city get, you still have this distance guaranteed. Other example. And economically speaking, and this we probably link with the end of today with Frank van Oort. Now we can imagine that you can reach certain economy of scales, scale and agglomeration, and which are the results of being all together, no? The distance, the proximity, and so on. We usually are connected with having more money, more creativity, more per capita, more access to transport, to services, theater, university, hospital, and so on, whatever you can imagine. But without, ideally, paying the cost of this economy. Pollution, traffic, congestion, climate change related to the gas emission, greenhouse gas emission for the transportation, for example, and also mental and physical health. Okay, this is the last slide, because some of you may have noticed that this is it may be also be labeled as part of the big family of the working cities or X-minute cities. There is a brief historical background about that. Okay, I finish my time, and here I am again. There we go.
Thank you, Luca, for your presentation. It certainly gives us a lot to think about. And for all the attendees of this webinar, I would request them to please introduce themselves in the chat and ask any questions that they have in the Q&A tab. We will, along with the name of the presenter that they want to address the particular question to. After all three presenters are done with their presenting, we will ask those questions to them. And now moving on to our second presenter, Tommaso Gabrieli. Tommaso Gabrieli is an associate professor at the Bartlett School of Planning, UCL. A theoretical economist by training, he is one of few economists working at the interface of urban planning design with economics of finance. He has conducted research on a wide range of topics, such as house price modeling, the socio-economic dynamics of cities, housing affordability, financial models for urban development. He has been a co-investigator in the Horizon 2020 Urban Maestro project. He is currently leading the Future Urban Growth Lab project at UCL. Welcome, Tommaso. The floor is yours.
Thank you very much for the introduction. Can I check that you can see the first slide? Yes?
No, currently, yes, we can see the slide now. Thank you.
Okay. So I met Luca many years ago, exactly 10 years ago. It was 2013. He was finishing his PhD working on Isobenefit Urbanism. And I am an economist by training. At the time, I was working at the University of Reading, but still doing a lot of research on urban economics and real estate economics. So I got interested in his approach because I could see connections between the general equilibrium model and his ideas around isobenefits. But it actually took many years before we could start to collaborate on a specific project. So the occasion came after I moved to University College London. I started working at Bartlett School of Planning, and there were few funding opportunities for applied work. So the idea of the Urban Growth Lab is to use the isobenefit approach in order to imagine future city growth scenarios. And we were successful to get a number of small grants. So here there is a long list of projects, but actually all those projects are quite small in terms of money and also in terms of duration. But we have been working with the isobenefit approach since the summer of 2020. And thanks to these different schemes that we were able to find at University College London, we have essentially done two things. The first one is to develop the code, to move from a theoretical code towards software output, and to engage with some local authority planners on ways to operationalize the isobenefit approach in a way that planners can find useful. So the idea is a slow and gradual development of the code, trying to create an applied tool that planners, but also citizens associations, broadly speaking, policymakers, and everyone interested in future growth scenarios could use. So in this presentation, I will focus on some of the software outputs from our project. Just to say that many different researchers have collaborated so far with us, and essentially there is more than one researcher that had quite a important role in developing the software applications that I will show. And just to say that, of course, all the theoretical framework comes from the isobenefit work of Luca. This has been published in different outlets, showcased also at Venice Biennale, and I really recommend to visit his website to understand much more about the isobenefit approach. And as Luca mentioned, one of the attractive features of the isobenefit approach is that theoretically it's very simple, just like the basic urban economics model, I would say, from the perspective of an economist. So in principle, you can do a lot with this general approach. So there are three types of cells that we are using. The built environment, think about residential areas, green spaces, and centralities. Centralities are like city centers where you have transport and retail centers. And the basic rule of the code is to model growth scenarios whereby all the new residential areas will be close enough to the green spaces and to the centralities. So there is this idea of, well, similar to the idea of the 15-minute city, but we believe that not only the approach of Luca came a little bit earlier than the 15-minute city slogan, let's say, but of course it is also more general, because with this Isobenefit approach, you can essentially model a 10-minute city, a 20-minute city, and in principle there you can even vary those distance-based rules. So it's a very general approach. As Luca said, in the moment in which you don't have constraints, so imagine a very vast green area that can be developed, and you are totally free to place new centralities in different places, you can have infinite Isobenefit scenarios. Whereas in our project, we really try to do applications to the UK to see whether we can have a tool that can help actual planning decisions. So the first application that I want to show is about a small area nearby Cambridge. We know that the local authority there wants to develop residential space, and for the standards of the UK, this would be a large plan for growth, something like 100,000 new residents. Okay, so essentially, how do we apply the Isobenefit approach? Here we have constructed a QGIS plugin. So from QGIS, we get to know the existing urban areas, the existing centralities, and the existing green spaces. And then we need to decide the type of growth that we want. So essentially, here we specify 3 types of densities: low density, medium density, high density. The densities are described by the number of inhabitants per unit of space. And we decide that we really want a balance mix of the 3. And then we can also model the probability of new centralities. So, as I said, the code is simple, but there is a lot of flexibility once you change the basic parameters, which of course are the probability of new centralities, the size of the grid that you are working with, and the densities. Okay, and here is the simulation output. So here you have new residential space. Those are all the cells that are orange, red, and dark red. And you have 3 colors because you have 3 different type of densities. And here you're also allowing for new centralities. Just to say that depending on the size of the cells and the density parameters, actually you have different types of residential space, of course. For example, in the previous simulation, essentially what you had was 60 inhabitants in each cell, okay? And therefore, you can imagine different ways to accommodate those this number of people in the cells. So of course, one possibility would then to be even more granular and then check for different types of dwellings that essentially are compatible with the simulation output. Another application that we did was in the south of England, the area of the New Forest. it is a very natural area with a lot of natural amenities. Even there, the local authorities want to increase the number of residential dwellings. They have plans, and so we tried the Isobenefit approach for that area. We are using the same approach that you saw before, but because it was developed from a different researcher, rather than using Python, here we are using NetLogo. And this is also to show that because the Isobenefit approach is very simple, you can really code it with in different languages, and in terms of visual output, you can have different type of softwares that you can use. So same idea as before, we need to specify the density, the size of the cells, the number of centralities. And essentially, here you have a first simulation in which you allow for new centralities everywhere. And basically what happens is that between the two existing cities, you of course end up having new centralities and new residential space. And in the second simulation, we imagine instead to have more planning constraints. So we exclude the green corridor between the two existing villages. And therefore, in that case, we will have more development concentrated around the existing villages. Another property that you can explore is the speed at which you essentially accommodate the existing population, because essentially here you have an algorithm that keeps looking for places where to put new centralities and new built areas. And of course, the less constraints you have, and the quicker is the job. So you could even think about those simulations as a way to represent or understand better the typical speed of development. Because another property of this approach is that as long as you can add centralities, then you have more options to fit new built areas. Okay, so one could imagine that in the actual development strategies, sometimes planners need to plan in phases. So first they build a certain number of dwellings, and then there is a later phase, and essentially allowing for centralities to be placed gradually in time could represent developing in phases. This is another simulation at an even smaller scale for the area of Portsmouth, just to say that we have a lot of exercises. And then lately, we are trying to model a network analysis. So now we are back with this slide in the case of Camborne, nearby Cambridge. And essentially, what we do here is we construct a network type of analysis. And here you have a first type of this analysis, in which essentially for every new built area, so essentially we need to translate the previous results of new built areas into a grid. And then for every new built area, we compute the distance from areas of interest. At the moment, in this slide that you have, we are measuring walking distance. And for example, here we have walking distance from bus stops, and then walking distance from schools, walking distance from doctors. So this is just to say that once you have simulation results, you can also do those ex post transport type of analysis. And of course, a further development would be to make some of those transport modes endogenous. So essentially to introduce isobenefit rules in which the 15 minutes distance is based on the actual existing network, and in the moment in which you create new residential places, to model that you could also create new roads or new transport routes. And I'll finish here because I think that my time is just over.
Thank you so much for your insightful presentation, Mr. Tommaso Gabrieli, and for explaining the operationality of how the code will work in isobenefit urbanism. And our next speaker is Frank van Oort. Frank van Oort is a professor of urban and regional economics at the Erasmus School of Economics, Department of Applied Economics, and fellow at the Tinbergen Institute. He studied spatial and business economics at Erasmus University Rotterdam, where he defended his dissertation on urban growth and innovation in 2002. His research focuses on regional economics, urban economics, FDI, and regional development, housing, regional competitiveness, spatial econometrics, labor market matching, subjective well-being, urban and regional policy and governance, and social and sustainable conditions for economic development. He combines academic research with applied research for cities and provinces in Europe, the OECD, the World Bank, and the EU. The floor is now yours. Thank you.
Thank you very much. That's a whole list, if you read it like that. But okay, I work on Erasmus University Rotterdam, and that means I also work with IHS, and that's why I met Luca before. So we work together on urban economic questions and urban planning. And I'm presenting today something about spatial structure, urban hierarchy, and productivity in European regions. And it's actually a plea for isobenefit urbanism, like it was presented in the two previous presentations. Because if you look carefully in what comes out of these exercises, a kind of agent-based models, what we notice is that it's a very polycentric kind of urbanism that comes out of it. So it should be about 15 minutes walk, which is about 1 kilometer, 1 mile in radius. And then you get, at least in the first presentation by Luca, you see different nodes which are spotted over space. And surrounding these nodes, there's a lot of green. So it actually suggests there's a lot of potential for polycentricity. So not very large cities that grow bigger and bigger, like London, but smaller scale cities that are very good accessible. There were also very good connections by rail in this simulation made by Luca. And the idea is that is also good for economic growth. That's actually where Luca ended his presentation, like what are the economies of scale if you have not a very large city, but you have smaller cities well connected. Can they actually function as a large city in an economic sense? Because that would be ideal. Then you don't have the disadvantages and you can have the advantages. So if we look at urbanization, it's always seen as a source of opportunities and differences. So we have a lot of urban areas in the world. More and more people live in urban areas. Why are urban areas good for an economic perspective? Well, if you are in a city as an employer or an employee, you have much less search cost. Less search cost for finding the right employee if you're an employer, so that's about matching. You have much less search cost for the good subcontractors and the good services like hospitals, universities, all these things that were in the models we just saw. If they are very good accessible and very nearby, you don't have to search far for it. And this is called urbanization externalities. If you have one person living there, you don't have so much of the advantage. With many persons, they can profit from the same kind of services. You have something which is called an urban premium, because so many people can profit from this things being proximate to each other, that it's something that's very valuable. So the first hypothesis usually tested in economic models is if you have a larger urbanization, a larger density, that's probably good for wages and good for people to find jobs. But on the downside, it was also mentioned already by Luca, you have congestion, pollution, and price increases for labor and land. So there might be some optimum solution, and maybe this optimum solution should be something like this polycentric structure. So how to measure polycentricity? It's about different axes. It's the axis between monocentric and polycentric, and centralized versus dispersed. And what we saw in the models which were presented in the first two presentations today, they are a bit more on the bottom, while the pure monocentric centralized urban models, which we see on the top left, for instance, that's something we see a lot also in other types of countries like China, where there's a large urbanization in very large cities, and then the countryside actually remains quite empty. So this framework I'm presenting now for Europe, I also try to explore it in China and even in Mexico and African countries to see how this differs over the different countries to research. So we should somehow try to measure polycentricity, and this is polycentricity in a morphological way. So how is the structure in space? There's also polycentricity in a functional way, like if you live in one city and you work in another, or you go shopping in another, then you have functional relations. And they are also very interesting to research, but they are not in the research I present today yet. And I'm working on that in the future. And then it comes very near to what was presented before. So an alternative hypothesis for the urbanization thesis being good for matching, sharing, and learning is polycentricity can have a positive effect. And actually, if you look at Europe, where this research is about, Europe doesn't have very large cities. It's a very polycentric structure in Europe. So we have some medium-sized cities like Amsterdam, Utrecht, Rotterdam, Lille, Brussels. They are not very large cities, but together they make an urban network. And this network idea is what is very central in the punctiform city that was actually introduced by Luca before. There's also an idea that if all the cities in a region are relatively small, there might be an advantage from polycentricity. So then you don't have to have everything in your own city. You can borrow it from your neighbor. So if your neighbor is nearby, you can borrow from that neighbor. But if one of the cities in the region is extremely big, so for instance London, and then the rest of the cities in that area are very small, probably it's not that you can borrow it. It's probably that London is actually casting what is called an agglomeration shadow over those surrounding areas. So the hypothesis is that polycentricity works much better if the average size of the cities in the region is small and they're equal to each other. If there's one city much larger, it probably absorbs all the benefits of matching, sharing, and learning in itself. And that is the third hypothesis. So we will try to test those three hypotheses in Europe. We collected a lot of data on a few hundred regions in Europe, and then we looked how is within Europe the spatial structure of cities organized. So is it one large city, or is it many small cities like in the Netherlands? You have Amsterdam, Rotterdam, The Hague, Utrecht, and they form a functional city more or less like what was presented by Luca, because they are very good connected by transport, and the areas in between are kept empty for recreation. So we test in a model. I'm an economist as well, so we test models. We test total factor productivity in those regions, a few hundred regions in Europe. And total factor productivity means how much output does someone create who's working there, and we control for capital intensity, because if you're specialized in very capital intense sectors, you're of course much more productive than if you're specialized in hairdressers. So we control for the capital intensity, we control for human capital, and then we're interested in the size, polycentricity, and infrastructural connectivity of those cities within those regions, if that matters for this total factor productivity. Of course, we have an issue about causality because, well, spatial structure may lead to factor productivity, but if you're very productive, you probably also attract highly talented people, and they actually want to live in green areas. So you also then determine the spatial structure again. And we try to control with that with instrumental variables, which I'm not going to discuss, but we do try to control for all these relations, because as it was mentioned by the previous speaker, a lot of things in the end are endogenous on each other. And so this is becoming a process of growth and a process of development which you can actually model. And it's important to know what kind of parameters you should actually put in these models. So how to measure polycentricity? Well, we make a rank size rule, which is already a very old instrument introduced by Mr. Zip. I think it was one of the old guys on one of the slides by Luca, which we show. So we have the rank on the horizontal axis and the size on the vertical axis. And in the Netherlands, you see Amsterdam is the rank 1 and Rotterdam is rank 2. The Hague is rank 3 and Utrecht is rank 4, but the line is quite is not so steep because there's what we call polycentricity. The cities are very similar in their sizes. But if you look at the region of Warsaw on the right in Poland, you see it's a very steep line. So that is quite a monocentric region. So within the region, the different cities are organized in a way that it's extremely monocentric. And this we put on all these hundreds of regions in Europe, and we make a measure for polycentricity for it. So what do we find? We hypothesized a positive effect of size. So the larger the city, the more matching, sharing, learning opportunities for employees and employers. And we actually find that always. So size is always good for economic benefits. Polycentricity in itself is not. So if you have only a spatial structure that is characterized by polycentricity, it's not favorable for your economic growth potentials. But the third hypothesis is very interesting. It's the interaction effect between size and polycentricity. So if all the nodes are actually quite small, polycentricity does have a positive effect. So if all the regions, if all the cities in the regions are rather small, together they are actually strong. Together they can make up for the loss of agglomeration power because they don't have a large city. But if one of the cities is much larger in a region, so the size is big, then polycentricity does not play a role. So this actually very much coincides with the findings of the previous two settings, but this is a formal testing that if you have this polycentric nature of equally sized, rather small nodes, it's a network and you connect them very well, because I don't show here, we also control for connectivity, which is important. Then you can have much more economic effects than, or the same economic effects than if you are in a large city. So the takeaways are size matters for European regions, but so does spatial structure. The borrowing size becomes very advantageous when there are much more smaller cities that are well connected in the region. And where are we looking now? Well, the period of testing here is 2010, 2012. And that has some peculiar aspects because of the crisis. So we look at other time frames. We look at other controls for the endogeneity issue. But one thing might be to just use a model as was presented in the previous presentation to see how it will go if factor productivity influences structure and the other way around. And we also try to do this in China and in Mexico and in other cities now. So I work together with PhD students and students from IHS who use the same kind of modeling in other settings. So I think this ends my, thank you for your attention. And maybe we can have some discussion as well.
Thank you so much for your presentation, Mr. Frank Van Oort. We do have a couple of interesting questions. I'd like to start with the question from Iliari Aguilar from Lima. I think this question is directed towards Luca because it was during his presentation. And Iliari asks, green areas must be natural areas. What happens with cities located in the desert?
In the desert,
Yeah.
look at in the desert. I think you can do whatever you want, because if you're going to build a city in the desert, you already quite a mindset toward complete central planning. And you have no limitation at all. You can build a spaceship in the desert. So no, apart from that, it's not a joke, because look at what they're doing in the desert region actually. Well, there is no nature, so I'm not sure how much we should obstinate ourselves to build in a completely, naturally speaking, unfriendly situation, because it implies a huge amount of money for everything you can imagine. But okay, if you don't have other option, it is a must. Okay, if you are able to build a city from scratch in the middle of the desert, maybe you're also able to build nature from scratch just around the city. Maybe. But I'm not sure. We should ask the expert for the sector.
Thank you. But like as an add-on to this question, since I'm originally from Delhi, and Delhi is really not much walkable during most of the year. So I think this is another facet to this particular question. Like we are talking about 1 mile because it is of the walkability. But what if the natural conditions are such that it is not walkable? So then again, we have that infrastructure come in that we're designing around.
Yes, not workable because of the dependency or because of the shape.
Thank you.
It's because of.
Sorry, please continue.
Yeah, can you hear me?
Yes.
Yes. No, I meant it's not workable because of the dependency, because it's near the mountains, or is because of the. It is a question to you, or because of the other things. Why is not workable?
Because of the temperature, because it's too
the
hot.
temperature. So, well, that is another issue. Yes, of course. Yes. Well, that is a completely different scenario. But I have a solution. If you see the videos, somewhere you can notice the tapirulant, urban tapirulant. So you may be enclosed. Of course, it's expensive solution, but they are enclosed in this case, for the air conditioner, urban tapirulant maybe. But we are talking about science fiction almost. But you never know. Maybe in 25 years it will be the normality in these old countries.
Thank you.
Is
And
it
I think the
possible
next
to
question
ask
is...
something to Luca related to this?
Yes, please, of course, go ahead.
Luca, as you remember, one month ago, I asked you to make a visualization of the part in the Netherlands I live in, because, well, we don't live in a desert, but we do live 5 meters below sea level. So there's a real threat that we get sea level rise, and then a lot of areas will be flooded. And the area that will be flooded first is the area that's most populated. It's Amsterdam, Rotterdam, The Hague, and Utrecht. So no, we are not that stupid that we want to plan something in the desert, but this desert is actually coming to us in a way. Is your model able to somehow say, okay, if that happens as a scenario, what would be the main solution? Can you still connect the cities somehow and keep them working? You have to protect them probably very well, but then you should give up the other part of the countryside maybe? Or would you say, no, you have to retreat completely and build a new punctiform city somewhere else, like on the higher ground? What would you advise?
Yeah, well, it's a question of cost and benefits, I think.
Yeah.
But if you are rich enough to have, well, quite sure is, I think it's economically, but also on the daily basis, more convenient to even have a more punctiform city, because you have just small point, and so you concentrate everything's there, including effort, meaning the barrier, the things that you are wonderful in this for the water. And then once you have this, you adjust under aspects to connect them. So I can visualize this SkyTrain. I don't see any other solution there. SkyTrain or the tunnel as the manic here from England to reach the England from Paris, from France. And So SkyTrain to connect each of these few points in the middle of the ocean, as the picture that I sent you was visualizing, and or, but that it would be a catastrophic scenario. Really, I hope we will not reach there to move inside. That's it, toward Germany.
Yeah,
but I think no one know about that. Or maybe, as you are still used since the past, I'm not sure the engineering, if they said that it would be feasible to even have stronger and the highest barrier against the sea as it is now. So maybe you can just keep as it is now. Maybe
well,
that should be a cost benefit from an engineering point.
But this is not only in the Netherlands. This is also in India, Bangladesh, Indonesia. They have all these deltas have this problem. So it might be interesting to look into it somehow, because then you make the city islands and you connect them. Okay, but that might be very easy.
Yes, actually, where I'm here, the University of Bournemouth many years ago asked me about this point. Actually, I think they're still now interested about this because now we are constantly where I am now, the south coast of England. Literally every year I back, I can see a little bit less. So sooner or later, most of villages and some cities may have an issue. And they ask me, so what? Or we call the Dutch, and we ask you to build your engineeristic structure here too. Or we move away, or we build this point that may be easy to be threatened. This pontiform city, yes.
Thank you. The next question, I think, is directed towards Tommaso Gabrieli. This question is from Babak Pirzadeh. And Babak asks, polycentric development is a serious threat in the unbalanced development of cities in third world countries. And this leads to the development of informal settlements in these cities. What solution does this attitude, but I think what he means is model, provide for development management?
Okay, thank you for the question. And I read through also the other questions, and maybe this answer helps, to clarify a few issues. So, the first point is that, as I said, this application of the Isobenefit approach is based on very few variables and parameters, right? Because essentially we are just making a distinction between built areas, centralities, and the green areas, okay? So, I mean, in a way, one could say we are just, using this model to plan for growth, and this new growth is formal growth, basically, a planning system whereby the public sector gives permission for new buildings, and then new buildings follow. Okay, so the first consideration could be, okay, we are not really using this model to discuss informal settlements, but actually, as it is often the case with simple and general approaches, if you are a bit flexible and if you are a bit smart, you can use some of the basic principles in different, for different cases, for different situations. So actually, I think that one may find useful this model to discuss specifically informal settings, because one could say, okay, let's understand a specific case of informal settlements in India or in Latin America. For sure, the informal settlers have preferences to be close to certain amenities, to certain locations, right? So essentially, you could try to have different rules, okay, that represent the preferences of the informal settlements, and you could get some ideas on how informal settlements could grow. So, I mean, my basic answer is, as it is the case with general approaches, if you are, quite flexible, you can use it to represent growth in different contexts. And I mean, if I may, I basically give the same answer also to someone else that was asking whether this applies more to new cities or to change in the urban morphology of current cities. I mean, as we are discussing, is a general approach that can really be applied to both those situations. And essentially, what Luca has shown with the more theoretical simulations is, if you wish, a case in which you're really building new cities from scratch, because he was basically showing all those simulations in a huge existing green area, whereas all the simulations that I have shown were about urban growth in existing urban contexts. Okay, and in fact, my simulations were at a smaller scale, and once you do that, in terms of coding, it becomes a bit more challenging. As I was showing, you really need to feed all this information about where are the existing urban areas, where are all the green areas that you cannot urbanize, for example, public parks, natural amenities. But once you feed all this information, then you have results in terms of where you can place new buildings, and therefore how an existing urban context can be expanded.
Thank you so much for that insightful answer. And I think we're 3 minutes over time. So just as a last question that I would address to all three presenters is a question from Javi Zhu that asks, does the model include the parameter that considers to compensate the green footprint of the newly built area? So I think what this question is trying to ask is that this model really helps to control the sprawl. But what if we have too many centers of growth, but that itself will maybe kill the biodiversity a bit? So your thoughts on that, please. Luca, you're on mute. You need to unmute yourself. Sorry.
Sorry, what he said? What if we have instead several centralities? What?
Sorry. So I think what this question is trying to ask is that isobenefit urbanism aims to, one of the externalities is to control the sprawl. But what if we have a lot of centralities, a lot of centers of growth all around? Wouldn't that itself, if we don't accommodate for that, won't it, how to put it? Sorry, I'm just trying to find words to explain.
Yeah, no, I think so. Many years ago, I got the same question. It was a very clever question from a student. I think she was from Africa at IHS. I think it was one of my last year there. And yes, no, somewhere, I don't remember where, I wrote in a publication, I also defined these, wait a moment, it was a nice terms. was something like a dispersed concentration, something like that. Rather than, I don't remember what, I had to read again the papers where I wrote that, because, is, I think, yes, as long it enables, it also, well, maybe not encourage, but it allows this dispersed, so spread, but concentrated in terms of points or whatever. But as long as they are concentrated in terms of physical proximity, not necessary density. And this I'm start also understand this density, because years ago I was a bit more into these density things too. But actually, maybe I'm being biased after 15 years of England, of green villages in England where I am now. I'm starting appreciating too the low density. And also I read a lot of papers in which they actually, it's not so easy, right, to quantify the benefits also in terms of carbon emission for transportation for density or low density. Because, well, just an example, talking about this question about dispersion, centrality, sprawl. Here, I had to take the car to go to the supermarket, but in 5 minutes, I'm there without stopping once, because there is no congestion or traffic. So this, it generates much less energy use, emissions, and stress than having the same kilometer by the car, but stop and go all the time. So low density sometimes is not really the end of the world, but what it may be the end of the world is that you have to be forced to use the car literally for everything. So it's a dispersed, it doesn't matter how spread it is, but concentrated in these little walkable islands. So, yeah.
Maybe I add a bit that there are two competing models. There's a book by Matthew Kahn who says, well, if you have everything concentrated in large cities, at least that is very polluted. That has a very big footprint. But then all the outer areas are free from pollution. But as soon as everyone goes by car, like Luca says, like he goes 5 minutes there and someone else goes. So if there are sky trains, like Luca showed, yeah, it's great. But if you cannot afford the sky train and you go by car or bus, and you have a very dispersed area, I can imagine that also the footprint is spreading. But that you should actually build in the model somehow. Some people say, have it concentrated in New York City, then you know for sure that's a very unhealthy place, but all the other places are relatively not affected. Versus if you spread it, you probably get lower degrees of pollution, but it's in a larger area. So I think there's a trade-off. There's a kind of cost benefit again. And I think this model might actually be able to help in this, as long as you have the good variables and relations in it. But that's something for the future probably to look at.
Thank you, everyone. I would like to thank all the presenters on behalf of the IHS International Alumni Board for taking the time out to share their views with us. And I think we're almost 10 minutes over from our scheduled duration. So I think we can end on this note. And thank you very much again. And thank you to all the attendees for the questions.
Thank you very much.
Thank you.
Thank you.
Ciao Tommaso. Hello Frank.
Pleasure.
Thank you.
Bye.
See you.
Bye bye.
See you.